This is TWiT.
Well, you know, I mentioned at the first of the show here that I had a new piece of test equipment I was real excited about and wanted to show you about tonight. This is something that a transmitter manufacturer brought to my attention recently. I had seen one before. I've got a friend who has one, but I've never used one. And I finally broke down and bought one for myself here. This is a Flir 1, Generation 3. It's a camera, basically. You can hook it to your cell phone, either iOS or Android. This one is for the Android. It's got the USB-C port on it. So I just plug it right here on the back or the bottom of my cell phone. And now I've got a infrared camera here that I can do heat maps of things around the transmitter site. It's a thermography camera. That's another name for it. There's on the website right there. You can find this this particular model for around $200, and for that price, boy, it really works well. Now they make really expensive models going up into the tens of thousands of dollars for specialized purposes, but for my work around the transmitter site, boy, this was just the thing right here. Let's take a look at my first experience with it. I'm back out at the same transmitter site I was at last week, and we're going to do a little thermography here to see how things are operating and what the normal heat maps should look like. The first thing we're going to look at is a transformer here that converts the incoming Delta three-phase service into a Y connection. And we can see right away there seems to be a hot spot up there in the top of it. That's a cutaway vent to let heat escape. Let's go in a little bit closer and see what that is. Now we can see that's where the wires come into and leave the transformer. It's under 120 degrees Fahrenheit there. I believe that's okay. But it does really look frightening on first glance here in thermography. Let's take a look now at the main fused disconnect for the incoming utility. Because this device can only measure surface temperature, that fuse box doesn't look hot. But if we take a look inside, we can find some hot spots. Looking at the three fuses, they all are about the same temperature, just over 100 degrees, which should be typical. And this means that we're drawing about the same current on each line as well. We'll want to look above to the connections there and make sure there's no hot spots there, and there's not. If we look down below, though, we see one leg is a little warmer than the rest. Of course, it is right next to all the wires that are going down into the transformer, so that's not to be unexpected. But these are points of interest that we'd want to check on and make sure they're not too hot. Now, right down where the wires go into the transformer, yeah, still less than 110 degrees there. There's two transmitters at this site, a main and a backup, so there is a fuse box for each of those. Let's look inside the fuse box for the main transmitter. We can see just a little bit of heat at the incoming conduit to the box. Not much, though, but we really can't tell much from the outside. So let's open it up and have a look inside. The three fuses look about the same heat, and they all measure just under 110 degrees, so that means we got a good balance on the three phases from our transmitter. If we look at the terminals above those fuses, they all seem within reason too, a little less heat than the fuses themselves. And the terminals at the bottom of the fuses there, that's something you certainly want to keep a check on because those could get loose. In this case, they all look just fine. There's another fuse box on the wall that handles all the single-phase circuits, covers the air conditioning, and the various smaller pieces of gear in the rack. A look inside. Oh, I've got a hot spot myself, don't I? Well, we can see the main breaker up there for this panel. It's got a little bit of heat to it, not much. The smaller breakers below that are all relatively cool. There is one breaker over to the left bottom there that's got some heat to it. That is the air conditioner breaker. The air conditioner's not on at the moment. It was running a little earlier though. The transmitter itself, there's the conduit coming in. Of course, that's a fluorescent tube across the top there. Conduit comes in, and the first thing it hits there is the main breaker for the transmitter. Not very warm. There's a row of breakers across here. The one on the right's a little warmer than the rest, and that makes sense. That is the plate supply breaker. Then we've got some fuses down here, and it's kind of interesting. One is a little warmer than the rest. That is a filament fuse. Here's the other filament fuse. It's not quite as warm, so that's strange that there is a little change there, and maybe something I need to look into. The center panel of the transmitter really doesn't have any heat generating components in it. And then there's the business end of the transmitter, the PA tube. There's a little heat there. You can probably guess where the tube is located in that cavity, right near the bottom there. It's a lot warmer behind that door, but we're not going to open it up and try to look inside while it's on. If we look up above, we can see where the heat leaves the transmitter. That gets pretty warm up in there. That's closer to 150 or 160 degrees. Then the ductwork that exhausts the heat outside the building. What's kind of surprising there is back there on the rear wall where there's caulking around that exhaust pipe. That's actually warmer than the pipe itself. And I'm not sure, maybe it's because that pipe is metal that it won't show as high a temperature, or maybe because the air conditioner blows on it, it cools it off. Now let's look on the top of the transmitter. We can see the transmission line going up a vertical run there to an elbow. Of course, that's a fluorescent tube, the bright thing across the ceiling up there. The elbow itself doesn't look warm, but if we follow that transmission line on along, of course, another light, there's a flange connector right there. We can see a little heat is built up there. And then the remainder of the transmission line that runs on from there to the RF switch has a little higher heat map than the earlier part of the transmission line. Of course, the air conditioner doesn't directly blow on this either, so that might let it build up a little heat. There's the RF switch below there. And we're not really hot, just a little warmer than ambient. Now, if we look over here, this is an elbow going out through the wall to the transmission line going up the tower. Now, there's some heat there. Still not enough to be concerned with, but just kind of interesting how you have different heats at different points along the transmission line. Let's go outside, find the transmission line out here. We can follow it on over to the tower, and that is rigid line coming out of the transmitter building. And then there's a connector here where it changes to heliax. We definitely want to check that to make sure there's no heat rise there. And there's not. Let's look at the tower itself. This is interesting. I would not have expected the bottom section of the tower, where it comes to a point there, to be warmer than the rest of the tower. If we look up the tower, that's interesting. Those plates where all the cross members and the different sections are joined together, they're a little hotter than the rest of the tower. And you can see the guy wires up there. They're a little bit cooler. So this is a really interesting look at some of the things in the world that you wouldn't normally see. You know, when I first looked in the top of that transformer there, it looked like those wires were on fire, but really, you know, that thing is constantly adjusting itself for the relative temperature of everything that's in that shot. So It really wasn't that hot. I don't remember what it was now, but we saw the temperature there. But it was a little hotter than everything else around it, and that's why it stood out. So for doing work on high power equipment, for looking at your electrical utilities in the house, boy, this is a really handy tool there, and I think I'm going to get a lot of good work out of it in the future, because think of how much time it's going to save you if you can find maybe a loose connection or something that's heating up in advance. You can head it off before it's a major issue.